que acercar por el micrófono.
Buenas, soy Álvaro Franqui y mi compañero es Ángel Maya. Somos estudiantes de la carrera de Ingeniería Mecatrónica en UTEC. Nuestro proyecto básicamente se llama un robot, un topo, cuenta con 8 patas y mi compañero le va a explicar básicamente cómo es el funcionamiento del mismo.
Primero, lo que intentamos fue diseñarlo en herramientas como MATLAB y SolidWorks, que son herramientas de diseño. Y nuestro principal objetivo es que mediante solo 2 motores pueda realizar un trayecto, las patas de este mecanismo, similar a al de un mecanismo andante. Se diseñó y luego se imprimió las partes y posteriormente se realizó una conexión con una fuente de poder para que produzca este movimiento.
Cuando quieras.
¿Qué tal? Mi nombre es Mirela Rivas, soy estudiante de Ingeniería Electrónica de sexto ciclo y junto con mi equipo hemos realizado este proyecto que se llama ARCA, una asistente robótica para el cuidado de personas de tercera edad. Lo que queremos hacer con este proyecto es ayudar a las personas de tercera edad a sentir esa compañía que algunas veces sienten que no las tienen. Por ejemplo, yo tengo mi abuelita y cada uno de nosotros tenemos necesitos en nuestra casa. Lo que hemos podido aplicar con este proyecto es reconocer, comandar por voz un robot que pueda mover los brazos, pueda hacer distintos tipos de acciones y gestos para poder ayudar a la persona. Hemos utilizado para esto herramientas como por ejemplo Inventor para poder hacer las piezas. Hemos también podido utilizar distintos tipos de herramientas tanto de electrónica como mecatrónica, como la parte de lo que son servomotores, el Raspberry Pi, para poder controlar todo lo que viene a ser el mismo. Muchas gracias.
Buenos días, mi nombre es Esteban Palomino, estoy en el 7º ciclo de la Universidad de Ingeniería Mecatrónica. Felicidad. Buenos días, mi nombre es Esteban Palomino, estoy en el 7º ciclo de la Universidad UTEC. Como podemos observar aquí, estamos construyendo un proyecto que se basa en la recolección de botellas en la playa. Con este proyecto queremos nosotros recolectar las botellas que se encuentran en la playa, que nos dejan los bañistas de forma irresponsable. Queremos causar un impacto ambiental más que nada. Y en esta parte del proyecto estamos en la parte de diseño, como podemos ver en el póster. Hemos utilizado Inventor, hemos utilizado AutoCAD para sacar el tamaño de las piezas, las más convenientes. Y también estamos utilizando herramientas de prototipado rápido, como en este caso es Arduino, Raspberry y todos esos controladores. Como podemos ver, este es el primer bosquejo del robot. Este va a ser escalado y nosotros queremos quedar ok en la parte del básquet y las garras. Para enero esperamos tener un diseño finalizado y poder testearlo en las playas.
Good morning, everybody. My name is Facundo Garcia. I'm an electronic engineer currently on my 8th semester in UTEC. As you can see, my paper is already in English. This is given to I currently do some work with Purdue University and MIT, so I'm used to write in English, mainly for publishing papers, for example, in the I3E. So I explain to you my work. This work is named Autonomous Control of UR5 with Twin Delay DPG. What this work does is, currently robots are more affordable than ever, so in order to ensure that these robots can be applied for an average daily person, and you don't know a lot about robotics, you need to have an intuitive way to control them. So what we do is a new interface that is a human can communicate with a robot just using a reward. This is similar to how we learn. For example, when you need to learn to swim, like at the first time you don't know how to float even, but you start practicing and you start learning and you get rewards. For example, if you start swimming bad, that you start drowning and you don't like it, so that's your bad reward. But once you start swimming and you get to the other side, that's a good reward, and you start getting more rewards, and then you begin to learn. So This method is called reinforcement learning. It's a way for a robot to learn by rewards. So this is our model. This can be simplified by having like two people talking. The first is called an actor, and I say like, I think this is the best decision, and the second one is a critic. The critic says, I don't think this is the best choice, or it can say like, I think you made the right choice. So based on this, we train our model that is based on statistics and says like, depending on where you are, this is the best action you can take. So using this, we managed to teach a robot to reach certain poses and also like follow certain trajectories. This by like just letting it train in a simulation. We don't give it any orders, we don't explain it like what its environment is or how it's composed, it just learns. So it learns what its body is, it learns its environment, it learns everything by itself. So now I'm going to show you a small demo about it.
Tengo un reflejo, me voy a pasar para este lado para evitar el reflejo. Ahí está, perfecto.
Dame un segundo. Okay, this is a small demo I was talking about. As you can see, the robot manages to reach any position in space with quite a bit of efficiency and accuracy. It is able to reach any position in space in less than a second, which is very effective compared to other methods. And then to prove that this model is capable of adapting to other circumstances, we decided to, without teaching it this new task, see how it managed to follow a trajectory. And as you can see, the robot managed to do this task efficiently just by learning for 10 more minutes. So this is similar to what humans do, that we learn a task and learn a secondary task is way faster than the first one. And this is the behavior in space using a plot. At first, you see the reward during time. As you can see, the reward gets very high in a very low time. In less than 100 milliseconds, you get the full reward. That means you reach the point. And down you get the plot of the movement of the robot, the trajectory it followed. As you can see, there is a little bit of noise in the middle. It looks like a signature, but this is due because the robot wasn't trained to do this task. Like this couldn't be achieved with any other method. Like this robot managed to complete something new without practicing and without someone explicitly programming it. So this is the new the thing we are proposing for this project.
Hi, my name is Purisa Maya. I'm studying for engineering electronic at UTEC. This is my project, real-time single language recognition. My assessor is Victor Murray. Well, my project is about recognition single language for people that cannot talk. For example, in this block diagram, I present the process that I've been using to develop this project. First, I detect the regions that are skin. For example, here in this picture, only my hand has skin color. So I detect this, and the result is this picture. With this picture, I train a machine learning method with 50 images that has letters in single language. So this is my results, my accuracy, 82% for A, 80% for E, 86% for I, and 92 for O, and 92 for U. My time processing is about 60 milliseconds, which this I can perform live recognitions for using for live conference. For example, if you are in Skype, you can recognize the single language to talk with another person. And with this project, you can use it for talk with a person that cannot talk.